All right, guys, so remember, this video is just for entertainment purposes only. When you mess with electricity, it can be dangerous. Shut the power off of the refrigerator by unplugging it. Some tests that I did needs power to test the low voltage. Low voltage typically won't hurt you. All right, guys, Fix It John here. Got this GE refrigerator and the lights are barely coming on. My son just noticed it. And this light here is not coming on at all. And it's just an LED. What I found was, let me first show you while I have it out here. This light's not coming on at all. That one's barely coming on and this one's coming on. This refrigerator, we've only had it for probably a year and a half put in here. I think it's this LED here. If I connect these two solder joints together, the other two lights in the refrigerator will light up, but yet this one won't come on. And I'm feeling low voltage through here. But here's how you take these things off. Let me show you. You take your pick, and you just pull down and push in at the same time. There's little like clips. Uh-oh, there it is right there. And this one's on, so I'm not even gonna fool with this one. Let me show you this one here. See that one on? So obviously it has to make a complete circuit to brighten it up. Got those clips there. Same way with this one here. Got that clip, and that clip right there, right here, it came out on this circuit board here. You can see this light here, it'll get bright. And then the one here on the side panel will brighten up too. So you may be having this issue. It's how much brighter. So I would say this circuit board is bad somewhere. Unplug it here, just push this button in. That's all it takes. Pretty crappy. GE cares. All right, and that's another reason why I think this is bad here, because these lights aren't even coming on now to complete the circuit. So let me plug this one back in. See it come on? Let me see if you can. And then watch me short it out. Bam. Nice and bright. Now they're not coming on at all. Now they don't want to come on at all, guys. So I may have blown something when I shorted this out one too many times. Yeah, we'll figure it out. All right, guys, before we go replacing the lights, we need to check to see if we have power here, because it could be a few different things. I have my multimeter set on DC volts. So we're going to check the voltage here. Right there we have 2930 DC volts. Can you see that? So we have 30 volts. So we know we're getting power here. Now these run in these run in a circuit. So let's say, for instance, I take this one out here and I test for power. We need this one to transfer power over to this one. So if you do it with one of them gone and you check for power, let's do this one more time. This is where I'm putting my probes at, guys, right there on those two holes on the end, those two pinholes on the ends. So now with that LED gone, it should say no power. So see right there, we don't have any power. It's just ghost power right there. But if we plug this in, this is a working LED circuit board. So we'll plug this one in. All right, see those two holes right there? That's where that plugs into, right there, that plug and that plug. Plug that one in and just push it in and it'll snap in. Plugging it back in to show you we have power. 30 volts, DC volts. Now I'm gonna kick this switch off with my foot. Now you see the power dissipate, eventually going down to nothing. See, it's going down to nothing. Now I'm gonna take my foot off the light switch and then it goes back up to 30 volts. So that's how you know your switch is working too. Anyway, so if you're not getting any power here, it can also be your switch. You would have to test that for continuity. All right, guys, so if you don't have any lights in your refrigerator, it's like this, and you've already checked for power up here and you're not getting any power, DC volts, you want to check this switch down here. And that's the door on off switch. Let me show you how to take that off. I just use a putty knife and just pry it off, and it comes right out. So what we're going to check for is, remember which way this plugs in. We're going to check for continuity on this switch right here, and I'll show you how to do that. Unplug that one and that one. Make sure they don't go back up in there or you'll lose them. So, and here's how we check for continuity. You can either turn your dial to the ohm reading or to continuity. If you hear it beep, that means we're getting continuity. Just take that probe and this probe. Hear it? And that's what the, it's making a complete circuit's what it's doing in there. This is with the door closed. If it's not getting any continuity, you won't hear it beep. So with a working switch, you'll have an ohm reading of 0.5, 0.4, 345, something like that. And OL with it closed. That means it has an open loop. Here the switch is open. It's actually closed, but the current cannot go around because there's a break in it. All right, so we know the switch is good. That's how you can tell. If the switch is good, then it's the control board. And you've checked all the lights, replaced all those. So get it in there, you just plug it in. And voila. Very simple test for that. So there. We have a good switch, we have good lights, and don't forget your coffee. Mountain Grown. Okay. All right, guys, Fix It John. I just thought I could show you something here on these LED lights. Here is the bad one, and the resistance on this one, I have my own meter here set to for resistance. And this threw me for a loop here. This is the bad one. And the resistance on this one is 9.93. And you would think that was good, but then here's the new one that I bought for $7.59. Oh yeah, by the way, I found these online. All right, so let me show you the resistance for the new LED board. And there it is right there. It's a little different. I paid, the top one's the new one, the bottom one is the old one. I paid like $7.59 for the new one. So the resistance on the new one is 10K ohms. And that's higher than this one. You would think the lower the resistance, like this old one here, the better the circuit board. This one, it was at 10K ohms, and that other one you just saw me install was I wanted to test that too. That was at 10.03 ohms of resistance. So it was a little higher than even the new one, and this one was lower. So maybe for whatever reason, you know, I'm not an expert on this multimeter, but I do try to use it. It needs a higher resistance to work properly. I don't know. These are LEDs, and everything seemed to be working on here. I was getting the same numbers all over, so maybe just the LED burnout or something. I really can't tell you. I do like to get down and find out what it is, but in this case, I just know I got a bad circuit board. $7.59. I just bought one of them. I didn't replace them all. But let me show you this. I found this one. At first, I found a replacement on GE. I'll show you here. It was $79. And I'm like, I'll do without a light. And I was not going to buy a $79 LED board light here for $79 when it's only going to last a year and a half. There it is. There's a part number right there. Right there it is, WR55X26671. So yeah, quite the rip. There's the part number if I didn't already give it to you. WR55X26671 board. And I'm gonna plug it in and should have lights. This is the new LED board that I bought from Amazon. So boom, voila, we have lights. And we didn't need to call out a professional. Saved ourselves $100 or more. So there, that's on there. Let me get these covers. All right, and these covers here, they sort of have an oblong shape, sort of curved there in the front. Make sure you put them on the right way and you just snap them in. Like the rich kids down the street. If you guys like videos like this, like and subscribe. Give me a thumbs up. I really appreciate you watching. And if it really helped you, buy me a coffee. I'll leave a link down below right here. Fix It John, thanks for watching. Moving on to the next project.